This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we're going to talk about solving an equation in one variable. Let's take example number 1 from the book. It says 2x plus 7 is equal to 19. Now 2x plus 7 is equal to 19 is when you want to solve an equation, basically what your goal is to find the value of x. That means you want to know, for example, ultimately whenever you're done with all the steps that you're going to take while you're solving the equation, your goal is to arrive at an equation in the form, for example, x is equal to a. X, some value is assigned to a, and some value is assigned to x, and so that is your solution set of this equation. That means that this equation is valid for this value or these values, and so on and so forth. Now there is one thing that you need to know about how the book represents and of course most other systems go about solving algebraic equations. For example, if you look at the solution of this example in the book, you'll see that, for example, they say, for example, 2x they say it's written in the book that, okay, so I want to write this equation as x is equal to a. So basically I want to get rid of this 7, and so I need to subtract 7 from both sides of this equation to get rid of this 7, which is of course correct. Now there are some other systems that use basically different kind of terminology, but it's basically the same thing, doing the same thing. For example, according to the book, for example, you would say, okay, so I subtract 7 from both sides of this equation. That would be 2x plus 7 minus 7 is equal to 19 minus 7. So, and then this would be 2x 7 minus 7 is equal to 0, so it's equal to 19 minus 7 is equal to 12, right? But there are some other systems that would do the same thing, the exact same thing in this way or in this terminology. They say, for example, 2x plus 7 is equal to 19, and they simply say that, okay, so now in this equation I can, because I want to get rid of this 7 somehow, I don't want it to be somehow coupled with the x terms, so I just simply take it to the other side of the equation. So I would write this as 2x, take this to the other side, is equal to 19, and then when this comes to the other side of this equation becomes minus 7, and so 2x is equal to 19 minus 7 is equal to 12. So as you can see, it's the exact same thing, and I have actually subtracted a 7 from this side of this equation, so this side has become 2x, and again I've subtracted another 7 from this side, and this side becomes 19 minus 7, which is 12. But the terminology is slightly different, and the steps that you might see in solving the equation might be a little bit different, although like I mentioned, they're basically accomplishing the exact same thing. So now I'm accustomed to this kind of system. So for example, if I want to solve this, I would simply take 7 to the other side of the equation. So I don't have to write all of this. Or according to the book, for example, here to get rid of this coefficient 2, I would have to divide both sides of this equation by 2, which would be 2x divided by 2 is equal to 12 divided by 2. And then this would simplify and cancel out these 2's, and then x is equal to 6. Now according to this system here, you would say, okay, so you want to find x, you write x is equal to 12 divided by the coefficient of x, which is 12 divided by 2, which is 6. You will ultimately, basically both systems are doing algebra, but this system does things this way, this system does things this way. This is a little more I mean, it looks a little more organized, but this system works as well, and it basically gives you the right answer. So now the problem is I'm accustomed to this kind of algebra, and so I'm going to be following this kind of algebra, and unfortunately, if you're accustomed to this system, you'll have to learn this system with me so that we can move together. So that's basically the purpose of all of this video that I did. I wanted to just let you know that I do things this way, which is basically the same thing, but well. So let's do another example here. Let's do another example. This is 14.1, 14-1. So the other example is, for example, try number 1, solve the linear equation in one variable, 2x plus 1 is equal to minus 9. Now, in order to solve this equation, I can take this 1 to the other side of this equation, so this would be 2x is equal to minus 9 minus 1, and this is plus 1 going to the other side becomes minus 1. So then this is 2x is equal to minus 10, and then x is equal to minus 10 divided by 2, the coefficient of x, and so this is minus 5. So your x is equal to minus 5. That is your answer. Next, we have another, we can do it over here as well. So we have 4 into x minus 3, 4 into x minus 3 plus 12 is equal to 15 minus 5 into x plus 6. So 4 into, let me write this properly. So 4, what is wrong with my pen? So 4 into x minus 3 plus 12 is equal to 15 minus 5 into x plus 6. So in order to solve these kinds of equations, first you need to use the distributive property to first distribute everything. For example, you need to distribute this 4 into this whole expression, or distribute 5 into this whole expression, and then you can simplify. So this would be 4x minus 12 plus 12 is equal to 15 minus 5x minus 30. Then these two minus 12 plus 12 is just 0, and then you can take this minus 5x to the other side of this equation, becomes plus 5x. So then this would be 4x plus 5x is equal to 15 minus 30 is equal to minus 15. minus 30 plus 15 is minus 15. Now 9x is equal to minus 15, and x is equal to minus 15 divided by 9. Now you can divide the numerator by 3 and denominator by 3. This divided by 3 would be 5. This divided by 3 is equal to 3, so this is basically equal to minus 5 by 3. We have still some time. You can test these as well. For example, you had this equation, and now you find this solutions, and now you want to test it. You have to substitute this value of x into your original equation and see if that works. So in order to substitute, you would get 4 into minus 5 by 3 minus 3 plus 12 is equal to 15 minus 5 into minus 5 by 3 plus 6. And so this would be, I don't know, minus 20 by 3 minus 12 plus 12 is equal to 15 minus 25 by plus 25 by 3 minus 30. Now you can basically cancel these two out, and then minus 20 by 3, this is 25 by 3, you can minus 45 by 3. So let me see. So let's write this as minus 20 by 3 is equal to, this is minus 15, so this is 25 by 3 minus 15. So now let's do this side. Let's simplify this side. 25 by 3 minus 15 is equal to, let's say, 325 minus 3 into 15 is 45. So this is minus 20 by 3. So this whole thing becomes then minus 20 by 3, and minus 20 by 3 is equal to minus 20 by 3, which means that the value that we found there is correct. So that is how you solve these kinds of equations, and they're easy and fun. Of course, if you do them my way, not the other way. We have still some time, 5 minutes, so let's do another one of these. This is 14.14-2. 14-2. So solve the equation in one variable. Try number 2. The equation is minus 2 into 3x minus 1 plus x is equal to 14 minus x. So distributive property, minus 2 into 3x is minus 6x, minus 2 into minus 1 is plus 2, plus x is equal to 14 minus x. You basically need to take all the x's to one side and all the constants to the other side. So minus 6x plus x, this minus x comes to the other side, becomes plus x, and then you have this 2 over here, and so you write this as 14 minus 2. Of course, let me tell you something about the other method that we talked about earlier. I do use that method as well, but whenever I need to. For example, this equation right here is simple. I can simply take things around. For example, I can say, okay, so this is minus 6x, this is plus x, and this x comes over here, it becomes plus x, and then this is 14, and then this goes to the other side, becomes a minus 2. And so as you can see, in one step I have written this equation, whereas if I wanted to follow that way of writing things, then this would have taken me 4 to 5 more steps. But there are times when you just simply cannot do this kind of thing. When things get a little complicated, then you cannot do this, because you might make mistakes. So in some cases where things are a little more complicated, well, okay, you do that, and of course I would do that as well. But in simple cases, this method works as well, and it saves you a lot of time and a lot of writing. So now minus 6x plus x is minus 6x plus 2x, so it's minus 4x is equal to 14 minus 2 is equal to 12. So x is equal to 12 divided by minus 4, which is equal to minus 3. Now let's test if our answer is correct. So minus 2 into 3 into minus 3 is equal to minus 9, minus 1. So plus x is plus minus 3, which is minus 3, is equal to 14. So 14, sorry, is equal to 14. Now minus x is minus 3 is equal to plus 3. So this is minus 2 into minus 10. Minus 3 is equal to 17. And this is minus 20. Minus 3 is equal to 17. Now this is plus 20. Minus into minus plus. So plus 20 minus 3 is equal to 17. And 20 minus 3 is equal to 17 is equal to 17. That is correct. So that's basically how you solve a linear equation in one variable. Now in the next video we're going to talk about solving a rational equation. I'll see you in the next video.